This is an SOS video to help you prepare for the Q3 test. This one is on Unit 9 Inequalities. It is not teaching you or reminding you of all the concepts of the unit. You should go back to the other SOS videos if you need practice with that. This is simply to go over typical types of questions and how you should approach them. So for this first one, which inequality represents the accompanying diagram? When I take a look at this, I realize that each of these have a different symbol, and these all show the same exact slope and y-intercept. So I take a look. Since this line, the boundary line is dashed, I know that it can't have the equals to. So I'm not going to look at those two anymore. And I notice that from the boundary line, these lines are drawn down, which means it's less than. So it would be choice B. If you are looking at something, a question like this, and they end up having the same inequalities, say this was greater than, then you want to see, are the y-intercepts the same or are the slopes the same? And just be very careful. Remember, our y-intercept is where the line crosses the y-axis, and our slope is how far up or down you went, and then how far over. Change in y over the change in x. And this is a type of question that would be an extended response. So Alex has two part-time jobs. At one job, he works as a news carrier for X hours and earns $12 per hour. Remember, when we see per, you know that eventually you're going to multiply the $12 by something, by the number of hours. The second job, he works as a web designer for Y hours and earns $20 per hour. So Alex has some criteria. He wants to work no more than 22 hours a week. So no more means it could be 22 or less. So this is going to be less than or equal to 22. And he wants to earn at least $300. At least $300 is $300 or more. So that's going to be greater than or equal to 300. You have to write a system of inequalities. So system means more than one. So in this case, if it's only talking about two different things, we're going to talk about two different inequalities that can be used to determine the number of hours Alex can work as a news carrier and as a web designer in 1 week. We're going to graph the system. So I've already labeled your X and your Y axes. If it's not labeled in a word problem, you need to write those labels as well. I also gave you the intervals. So each of these boxes is worth 2. This is 2, 4, 6, 8, and so on. If your axes are not marked with the numbers, you have to figure out how best to decide how much each of those boxes are worth. All right, so let's first write the system of inequalities, and then we're going to graph the system. So the number of hours, he works for X hours as a news carrier, Y hours as a web designer. So the number of hours as a news carrier plus the number of hours as a web designer, he wants to work no more than 22 hours, so that's less than or equal to 22. That's going to be one of my inequalities. The other is how much money he's earning at each job. So $12 per hour, we don't know how many hours as a news carrier, but it is represented by X. So we have 12X plus $20 per hour as a web designer for Y hours, 20Y, that's got to be greater than or equal to 300. So one of the easiest ways to graph a real-life problem like this is to use our intercepts method. What happens when the y value is 0? What happens when the x value is 0? Because then I'm able to graph 2 points on each of the axes and connect them. So if I'm looking for my x-intercept, that's the x value when y is 0. So when y is 0, x would at the most equal 22. So one of the points is going to be 22, 0. If I'm looking for my y-intercept, that's my y value when x is 0. So when I put 0 in for x, y would equal 22. And the ordered pair would be 0, 22. So let's graph that. I have 22 zeros. So this is 20, this is 22. And then 0, 22 would be 0 and 22 over here. So you're going to take a straight edge and you're going to connect those two. Since it's less than or equal to, I know it's going to be a straight line. My boundary line will be a solid line. And less than, I go to the boundary line and I shade below. My lines are going to go down. And you're going to write your inequality somewhere in that area. You may want to wait until you graph the second inequality to make sure that you're not going over the solution area. Okay, I want you to pause the video, find the x and y intercept for this, and start the video again and see if you were correct. Okay, so hopefully you did this correctly, and now we're ready to graph those points. So 25, 0, well this is 26, 25, 0 would be here, and then 0, 15, this is 14, so 15. So I'm going to link those, and it's also going to be a solid line. Okay. Sometimes it's a little bit challenging to see which lines we're talking about. So let me go back to that again. And I am going to just go over this with a highlighter so you can see exactly what point I'm looking at. Now we want to have everything that's greater than or equal to 300. So greater than is above this line. So I'm going to start at the boundary line and draw the lines going up. So all that, remember you're going to the green boundary line, drawing all those lines up. Wherever these two meet, I'm going to see a cross section, and I'm going to write an S, unless they give me another letter to use, to say that that's my solution area. Remember, this whole section was 12x plus 20y greater than or equal to 300. So you have just graphed this. Now take a look at the last question, which is state one combination of hours that will allow Alex to work no more than 22 hours while earning at least $300 for the week. So what you want to do is find a point that's in this solution area. So what if I say I'm going to have 6, let's see, this is 14, 15. 6, 15. Now, in a word problem, we can't just leave it like that. You need to explain what the 6 and 15 are. So 6 hours was my X as a news carrier, and 15 hours as a web designer. And you can always check algebraically to make sure that this is correct. Remember, we said that x plus y had to be less than or equal to 22. So 6 plus 15 should meet that, and 21 is less than or equal to 22. We also said that 12x plus 20y is greater than or equal to 300. That was the other combination that had to work. So 12 times 6 plus 20 times 15 greater than or equal to 300. And we have 72 plus 300. So 372 is greater than or equal to 300. So we know algebraically that this combination of hours worked for both of these. This has been an SOS practice video for Unit 9.